Hello, Komal and Ashish. Have you done the second assignment?
Sir, so the paper you're talking about,
Yes, yes, yes.
sir, I'm still in study.
Okay. And by the way, so did you figure out the paper that you are going to present?
So there's another paper that we have.
Yeah. So basically, remember last time we talked about that there are these two assignments, and then towards the end, maybe in the last class or something, there could be presentation for half an hour, you know, or something where you can present, yeah.
So you gave us that book to study. I thought there's something
Yeah.
to
So you
study.
want to look at the so did you look at that computational quantum computational number theory?
Not yet, but I'm studying the paper. I have started.
Mhm. So when is our last class actually?
Sir, I think that must be around 26 April. Is from 26 we have session.
26 we have exam, right?
So,
So what I am saying that whether this presentation, do you want to do it in that week of 26th April or you want to do it before that?
so we can talk about that. I'll talk about that with students and update you about that.
Okay. So basically that means we have actually total 5 class including today, right? Before the exam, right? 2 and 2 4. So we need to somehow get some more time actually. How many total classes are possible now? One today and then two more, right? Four plus five. So one plus four plus one five, right? Total 5 classes are still left as per the schedule actually.
On 14th, 16th, first and
Hmm.
also there's one extra class, I guess, that on 7.
Yeah, so we need to take some extra class. So at one some point, whenever you people are available, let me know. So other people are coming, or should we start? What we should do actually?
I'll just make a call to Sir, Ajit just joined. I think we can begin the session now.
Okay, thank you.
Yes, sir.
Yes, can you see my screen now?
Yes, sir, it's visible.
Okay. So remember in the last class, we were looking at factorization of polynomials over finite fields, and I think I gave you uh, two methods. Today, we are going to mm, give you the last method, which is using the previous two methods basically. So we assume that that our polynomial is monic and square free, right? So let me give you. I mean, the method is known as distinct degree factorization. Okay, so this is known as distinct degree factorization. So we assume that fx, which is a polynomial in the polynomial ring fqx, where fq is a finite field with q number of elements, is monic, first thing, and second thing is square free. Square free. Okay, so we know that from fundamental theorem that x q raised to power r minus x is nothing but product of all monic irreducible polynomials of fqx, right, of degrees dividing r. Therefore, if we call fr of x as gcd of fx and x raised to power q raised to power r minus x, okay, then this polynomial is the product of all irreducible factors of f of x of degrees dividing r. Okay. So fx does not contain factors of degrees smaller than r, right? So if fx does not contain factors of degrees less than r, then fr of x is nothing but product of irreducible factors of fx of degree exactly equal to r. Okay. So based on these observations, we can give you an algorithm for doing the distinct degree factorization of the polynomial. So here is a yes. So here is the algorithm. Okay. So our algorithm is distinct degree factorization of monic square free polynomial. Fx. This is the input, right? And then what we do, we initialize a number r to be 0 and a polynomial gx as x, while fx is not equal to 1, we increment r and then compute gx is equal to gx raised to power q mod f of x, and then compute frx as gcd of fx comma gx minus x, and the output will be frx and r. Okay, if frx is not equal to 1, set fx is equal to fx divided by frx. The technique is almost similar as the previous one, and gx is equal to gx reminder fx. Let's close. So this is the algorithm for computing. So we can actually do an example so that it is clear what is happening. The example is, suppose fx is x is for 20 plus x is for 17 plus x is for 15 plus x is for 11 plus x is for 10 plus 9 plus 5 plus 3 plus 1 belongs to f2x. Now we can compute the GCD of fx and f prime of x. Why we are doing this? Because just to make sure that fx is square free. If since this GCD turns out to be 1, this implies that fx is square free. This is the previous algorithm that we discussed in the last class, right? There was a lemma that we have done, right? So since this GCD is 1, fx is square free. So we can compute what is f1 of x will be GCD of fx and x square plus x, which is 1. This implies that fx has no linear factor because this GCD is 1. So we compute f2 of x will be GCD of, I'm just applying the algorithm, fx and x is for 4 plus x. This is also 1. This implies that fx does not contain any quadratic factor also. Okay. So that means we go to the next R, we look at f3 of x, then this will be GCD of fx and x is for 8 plus x. This turns out to be, this time, not equal to 1, but rather x is for 6 plus 5 plus 4 plus 3 plus square plus x plus 1. Okay. So we have this GCD not equal to 1. This implies that fx has two irreducible cubic factors. So now we replace fx by f3 of x. And this turns out to be a long polynomial. X raised to 14 plus x raised to 13 plus x raised to 11 plus x raised to 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus x plus 1 mod fx. Okay. Now, sorry, this is not mod fx. Yeah, this is the replace fx by fx divided by f3 of x, right? So this polynomial we are dividing it this polynomial x raised to 6 plus 5 plus 4 3 plus 2 plus x plus 1. So we get this polynomial. Right? Now we compute x raised to 16 plus x, and this turns out to be x raised to 11 plus 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus x plus 1 mod fx. We reduce it to more, this thing mod fx. Now fx is a degree 14 polynomial here. So since f4 of x is nothing but GCD of fx and x raised to 16 plus x mod fx, this will be x raised to 4 plus x cubed plus x squared plus x plus 1. Therefore, fx contains a single irreducible factor of degree 4. A single irreducible factor of degree 4. And replace fx by, we are just calling the algorithm one by one, by fx by f4 of x, and this will be x raised to 10 plus x raised to 8 plus x raised to 7 5 plus 3 plus square plus 1. Now we compute next degree, which is x raised to 32 plus x. And this is congruent to 0 mod fx. This implies that f5 of x is GCD of fx and x raised to 32 plus x mod fx. And that turns out to be same polynomial. Okay. X raised to 10 plus x raised to 8 plus 7 plus 5 plus 3 plus 2 plus 1. Okay. So this implies that if f5x is this polynomial, this implies that fx has two irreducible factor of degree 5. So again we replace fx by fx divided by f5 of x. Okay, this turns out to be 1. So this loop terminates. Okay, so we obtain the following factorizations of fx. F1 of x is 1, f2 of x is 1, f3 of x is 6 plus 5 plus 4 plus 3 plus 2 plus x plus 1. F4 of x is equal to x4 plus x cube plus x square plus x plus 1. F5 of x is equal to x raised to 10 plus 8 plus 7 plus 5 plus 3 plus x square plus 1. So we need to still factor f3x and f5x, So that can be done next. Okay. So this is the example. So now I think we can look at the last technique known as equal degree factorization. So we can discuss equal degree factorization. Okay. So this time we assume that fx in fqx is square free, that is one thing, and is a product of monic irreducible polynomials, or I would say factors of the same known degree R. Okay. If degree of f is d, then fx is a product of d by r irreducible factors. So we need to find all the factors. Now the technique is similar to root finding algorithm that we discussed earlier, and there will be two cases when q is odd and q is even. So first let me describe q is odd case. So what we do for any alpha in fqx, we know that x raised to power q raised to power r minus x is same thing as x plus alpha raised to power qr minus x plus alpha, which is same thing as x plus alpha times x plus alpha raised to power q raised to power r minus 1 by 2 minus 1 x plus alpha raised to power q raised to power r minus 1 by 2 plus 1. Because of this factorization, therefore, our gx is something like x plus alpha raised to power q raised to power r minus 1 by 2 minus 1 mod f of x. And f1 of x is equal to gcd of fx and gx. This is a similar algorithm of root finding that we discussed earlier. So these two things are computed. Okay. And if degree of f1 is positive and less than degree of f, we recursively split f1x and fx divided by f1 of x. In fact, I can write down the algorithm now properly. So here's the algorithm. So we are factoring fx in fqfx and a product of irreducible factors of degree r. Q is odd, then the algorithm is given. If degree of f is 0, then nothing. Right? If degree of f is r, output is fx. Initialize the flag. The flag is split found to 0, while split found is 0. Choose alpha in fqx randomly. Choose alpha in fq randomly, and then compute g of x is equal to x plus alpha raised to power q raised to power r minus 1 by 2 minus 1 mod gx as promised. Then compute f1 of x, which is GCD of fx and gx. Okay, this is exactly good finding algorithm. If 0 is less than degree of f1 is, so if degree of f1 is positive but less than degree of f, set split found to be split found to 1. Then recursively call the algo on f1 of x, recursively call algo on fx divided by f1 of x. And finally, so this is our algorithm, how it works. Let me show you again by an example. Okay, so our polynomial is fx is equal to x raised to power 9 plus 3x raised to power 8 plus 3x raised to power 7 plus 2x raised to power 6 plus 2x plus 2 in f5 of x. So given that fx is the product of 3 cubic irreducible polynomials of f5x for alpha is equal to 2 in fqx. In fq actually we have gx is equal to x plus 2 raised to the power 5 cube minus 1 divided by 2. Q is equal to 5 here, right? Minus 1, which is same thing as x plus 2 raised to power 62 minus 1, which is same thing as 3x raised to power 8 plus 3x raised to power 7 plus x raised to power 6 plus 2x raised to power 5 plus 3x raised to power 4 plus 3x cubed plus 3x squared plus x plus 4 mod fx. And then, so once gx is known, I can compute f1 of x, which is GCD of fx and gx. And this turns out to be x raised to the power 6 plus 2 times x raised to the power 5 plus x raised to the power 4 plus 4x cubed plus 2x squared plus x plus 1. Okay. So the cofactor fx divided by f1 of x turns out to be x cubed plus x squared plus 2. So this is an irreducible factor of fx. So one factor is there. So other two factors are obtained from f1 of x. So we know f1 of x is this, right? So from there, we can again call the algorithm. So for alpha is equal to 0, g1 of x is x raised to the power 62 minus 1, which is congruent to 0. Mod, this time we have it f1 of x rather than fx. And then GCD of f1 of x and g1 of x is f1 of x. So it's a trivial factor of f1 of x. Next, we try some other value of alpha, say alpha is equal to 3. Then we obtain g1 of x is equal to x plus 3, 62 minus 1, which is congruent to 4x raised to the power 4 plus 4x squared plus 4x mod f1 of x. These calculations are a bit lengthy, but and their GCD of f1 of x and g1 of x is x cubed plus x plus 1 is an irreducible factor of f1 of x. So the other factor of f1 of x is f1 of x divided by x cubed plus x plus 1, which turns out to be x cubed plus 2x squared plus 1. Therefore, the factors are, our polynomial fx is x cubed plus x plus 1 is one factor. X cubed plus x squared plus 2 is another factor. X cubed plus 2x squared plus 1 is another factor. So I described you an algorithm for factoring when q is odd, right? And similarly, there is an algorithm for q even. In a sense, I mean, q is when power of 2 actually. So let me describe that. So when q is equal to power of 2, yes. Okay. So in that case, x raised to power q raised to power r minus x can be written as q raised to power nr plus x, right? Factors for any alpha in Fq as x raised to power 2 raised to power nr plus x is equal to x plus alpha raised to power 2 raised to power nr plus x plus alpha. So we can write it down as x plus alpha plus x plus alpha squared plus x plus alpha raised to power 2 squared and so on plus x plus alpha raised to power 2 raised to power nr minus 1 into 1 plus x plus alpha whole square plus x plus alpha 2 square and so on x plus alpha raised to power 2 raised to power nr minus 1. Then we compute gx. Because the factorization technique is different, that's why oh, these quantities are different. The rest of the algorithm is similar. Square plus x plus alpha raised to power 2 square x plus alpha raised to power 2 raised to power nr minus 1 mod fx. Okay, and g and sorry f1 of x will be the GCD of fx in gx. Okay, so if degree of f1 is positive and less than degree of f, we can simply split f1x and fx of fx divided by. So we split f1 of x and fx divided by f1 of x, the cofactor. Recursively we do this and we can find the factor. So I think I'm writing the explicit algorithm for you in this case. So we have factoring fx in f2 raised to power nx, the product of reducible factors of degree r. Okay, so if degree of f is 0, return that. Okay. If degree of f is r, return f of x. Set the flag split found to 0 while split found is 0 to this, choose alpha in f2 raised to power n randomly. Set tx is equal to x plus alpha and sx is equal to tx for I is equal to 1, 2, up to nr minus 1. Set tx is equal to tx square mod fx and sx is equal to sx plus tx. Then we compute f1 of x as GCD of fx and sx. If degree of if 0 is less than degree of f, it's less than degree of f1. Sorry, degree of f1 is less than degree of f. Set split form to be 1. Recursively call algorithm on f1 of x and then recursively call on fx divided by f1 of x and then we close. So this is the similar algorithm as in the previous one, but slightly different because of the factorization technique. I think finally I'm going to give one example of this and then we are done with the factorization of finite fields. So let f4 of x, f4 is nothing but field with 4 number of elements, f2 theta with theta square plus theta plus 1 is equal to 0 and factor fx is equal to x raised to power 6 plus theta times x raised to power 5 plus theta plus 1 times x raised to power 4 plus x cube plus theta belongs to f4 of x. So given it is given that fx is product of two cubic irreducible polynomials. So for alpha is equal to theta, gx will be x plus theta plus x plus theta square plus x plus theta raised to power 4 plus x plus theta raised to power 32 plus 4 plus 8 plus 16, right? And finally 32, which is same thing as theta times x raised to power 4 plus theta times x square plus theta x plus 1 mod fx. Then we compute the GCD of fx and gx, and it turns out that x cube plus theta x square plus theta x plus theta is a factor of fx. So other factor is fx divided by GCD of fx and gx. And this turns out to be x cube plus x plus 1. Therefore, we get fx is equal to x cube plus x plus 1 times x cube plus theta x square plus theta x plus theta. And that's the final effect. So I think this is how we factor polynomials over finite fields. As a warning, I should tell you in some situations, these algorithms fail to split fx completely into irreducible factors. So of course, there are certain improvements, but that we are not going to discuss right now. This much is sufficient for factoring polynomials over finite fields. There is some other work done by Burleycamp on for factorizing on integer polynomials, but again, we are not discussing that. I think from now onwards, I'm going to look at some other applications. So maybe so I think I would like to ask you now, so, who is doing this, the parameter testing paper? Ajit, you are doing, right?
नो सर एक्चुअली आपने जो पेपर दिया था वो वर्ल्ड कैंप के ऊपर था.
हाँ, वो नहीं, बर्ली कैंप का पेपर तो बेसिकली सबके लिए है, राइट?
सर एक्चुअली वही मतलब जो हमारे ग्रुप था ना मेरा कोमल का सर वही हम दोनों मिलके कर रहे हैं साथ में.
ठीक है, ठीक है, ठीक है, ठीक है. और what I am saying that the other paper, the other one on. So now we need to give some sort of presentation. I am saying in terms of rather than exam, we can take a presentation of one paper, or maybe in the exam week or so. So which paper?
हाँ सर एक पेपर है A Tale of Two C Factorization.
You found one paper?
Tale of Two C Integer Factorization पेपर है सर, उस पे मैं और कोमल मिलके प्रेजेंटेशन देंगे.
ठीक है. और what about the others? So someone is doing primality testing also, right?
Yes, sir. I am Praveen, sir. I will talk.
सर उसमें सर.
Okay. No, AKS algorithm. What I was saying, AKS algorithm कौन कर रहा है?
Sir, I am doing with Praveen Pandey.
Okay, Praveen. Okay. You are doing alone or you are doing with someone?
No, sir. Actually, last time we discussed that we will be doing this presentation alone, individually.
Correct. The final presentation will be alone. So that's what I'm saying. So there should be 4 papers, right?
सर वो सर एक्चुअली उन्होंने बोला था इंडिविजुअली सर, पर मैं जब एब्सेंट था ना सर, वो मेरे को मालूम नहीं, मतलब पता नहीं था कि इंडिविजुअली है या वो ग्रुप में था सर। मतलब सर ऑनेस्टली सर मेरे को ग्रुप में करना था।
नहीं नहीं, ग्रुप में तो ये वाला पेपर था ना बर्ली कैंप का, वो सबको करना है ग्रुप में ना। सो देयर आर टू थिंग्स एक्चुअली। एक तो क्या है कि एक असाइनमेंट तुम लोगों ने सबमिट किया था विच इज वेरी गुड। दूसरा असाइनमेंट हमने दिया था बर्ली कैंप आई गॉट थिंक राइट विच वी पोस्टेड।
हाँ सर, वो
वो
चल रहा
ग्रुप
है
में,
अभी।
वो चल रहा है राइट ग्रुप में, ठीक है ना।
हाँ
और तीसरा जो है ना, एज ए फाइनल एग्जाम आई वांटेड यू टू रीड वन पेपर मोर एंड गिव एज ए प्रेजेंटेशन इंडिविजुअली। सो that paper I think did you finalize it or not, or maybe I should ask you which paper.
सर चलेगा अगर मैं डीएलपी में दे दो प्रेजेंटेशन, डिस्ट्रिक्ट लॉगरिथमिक प्रॉब्लम्स पे।
डिस्क्रीट लॉग प्रॉब्लम पे
हाँ जी।
ठीक है, चलेगा
ओके
चलेगा। सो
ठीक है, थैंक यू सर।
ठीक है, तो मतलब मैं ऐसा करूँगा कि तुम लोग अपना पेपर का टाइटल और कौन क्या कर रहा है वो मेरे को मेल कर दोगे तो अच्छा रहेगा,
ओके सर।
सो दैट आई नो हु इज डूइंग व्हाट एंड देयर इज नो डुप्लीकेशन। और एटलीस्ट मेल भी नहीं करना है तो व्हाट्सएप पे भेज दो मेरे को मैसेज, राइट। ठीक है
ठीक है ठीक है।
ठीक है, मेरे को व्हाट्सएप पे भेज दो, ये पेपर टाइटल है और दिस इज माय नेम, आई एम डूइंग दिस पेपर, आई एम डूइंग दिस पेपर, राइट, फोर ऑफ यू। तो आज नहीं तो कल तक मेरे को भेज दो, नहीं तो अगर देखना है तो तुम संडे तक करके मेरे को भेज दो कि क्या कर रहे हो, ठीक है ना। तो वो एक फाइनल प्रेजेंटेशन वी कैन डू इट फॉर बिकॉज आई हैव टू असेस आल्सो, राइट। हमने और कोई तो एग्जाम रखा नहीं है, तो ये दो असाइनमेंट और इस प्रेजेंटेशन के हिसाब से हम ग्रेडिंग करेंगे, ठीक है।
Yes, sir. And sir, I wanted to tell about the assignment. So, sir, assignment one we have done individually, me and Ashish. And assignment two, I think we will be also doing it individually.
That is fine. That is okay, no problem. So I have given you option of doing in a group. If you can do it in a group, that is fine. Because sometimes people say that if there are two people, they can read paper nicely. But if you can do it individually, that is very good. No problem. No problem on this. Right. So I can assess accordingly, and I think. So I think when you are going to submit this, the second assignment. So should we keep a deadline or something? Because now we have few lectures. Now I'm going to. So if you are doing this, then maybe now I can go into the, see there are two options. Either we go into this primary testing business and there are all the algorithms we do, or because but we don't have enough time now, but at least basic things are clear and maybe you can do it on your own also later on. But so we will be maybe doing the elliptic curve things, because that is also interesting thing. Okay. So
ओके सर, डन। इलेक्ट्रिक तो
elliptic curve will be better. So if I
हाँ
talk
हाँ
about that.
हाँ सर,
Okay.
कुछ नया सीखने को मिल जाएगा सर मेरे को।
ठीक है। So I we'll do the elliptic curve business in the rest of the classes, and we can take couple of extra classes also if required, right? No problem.
ठीक है
Okay.
ठीक।
ठीक है. So thank you for today, and that is enough. So next class is on Wednesday. Anyway, we'll meet on Wednesday, and then I think I will discuss with you when we can do the extra class. Okay.
Yes,
ओके ओके।
sir.
Thank you.
Thank you.